Okay. Hi, everyone. It is July 31st. Thank you for joining the Carpenter Working Group meeting. I'm going to go ahead and share my screen. Great. So far, I don't see anything that had been copied over from last week just yet, in which case we can get started uh, with Cameron.
Yeah, this is a question for from Michelle and I. Um, for the community question here, this is on the pull request in the AWS provider. Um, Basically, it's about spot interruption events specifically. Do we think Carpenter providers should be emitting that because it's a provider specific capability to have spot? I'm not sure if like Azure and Google has exactly the same concepts, or is that something that event should stay, should that event be emitted in Carpenter proper, and we should emit that or bubble that up through a condition? Sort of a technical detail, but it's unclear which project this really should span and be in part of.
Mhm.
Yeah, looking to see where we
There's a node event emitted right now, but there's no pod level events emitted for spot interruption.
I mean, my 2 cents, I guess I'd take a look at the issue as well, or the PR. But given that spot interruption currently is not an upstream Carpenter concept, it is something specific to the AWS provider, or at least two providers in general. I'm not sure if something similar is also implemented in the other providers. But for now, keeping it provider specific, unless we made a common concept of interruption upstream.
Yeah, I think so too. I am curious, how much noisier do you expect this to be? Like, how many events do you expect to be created then when you see these spot interruptions come in? Because it could be for a particularly large node with a lot of pods and then going on to every pod, right?
Yes. It's useful in terms of like trying to understand what happened to your deployment though. If you suddenly see that you're have a bunch of unhealthy replicas and you describe your deployment, then if it's a pod level event, it would show up there. Right now, it's sort of invisible to the users. Users can't see node events. They're in the default namespace. They might not have permission for that, etc.
So if it's going to every pod, would it, I'm trying to think if it would make sense to go to like the owning object and do like a single event there, like some pod disruption due to an interruption signal. I don't know, Jason, if you have an idea about that.
Guess I'm not sure. Are we really that concerned about the API server load for doing an event once per pod? I mean,
Not
relatively
really.
speaking,
I'm
you're
just
doing many events per pod during that disruption process anyway.
Yeah, I'm just trying to think through why we wouldn't do it. Um, and I don't think it's actually a concern.
Yeah, I'm trying to remember if Cluster Autoscaler emits an event for pod. I believe it does.
Yeah. I mean, we're already creating an eviction object per pod. I think we're already doing some events per pod during the drain process, though they're not necessarily getting emitted unless the drain is blocked. Like I don't think it's tremendously more API server load than what we're already hitting the API server with.
Yep. Yeah, I agree.
Okay, so consensus here is keep it in the AWS provider, and it sounds reasonable.
I think for the time being, I could see us maybe eventually upstreaming the concept of interruption, but
Mhm.
while it still lives in the provider, keeping it in the provider makes sense.
Yeah, I think the way it would be handled is kind of the same. right? Just where it lives is up to other providers. If there is that neutral concept, then I think we can bring it in, but until then, I think the AWS provider is perfect.
Okay. Any questions that you had, Michelle, that you wanted to ask?
No, I think that answered all my questions.
Cool. We can move on.
Great. So looks like pull request here. Pull this up. Oh yeah, static capacity. Samuka on the call.
Hey, yeah, I'm here.
Want to go ahead and give kind of an overview or update here?
Yeah, so we plan to build static capacity into the node pool by introducing a new field called replicas, which determines like if a node pool has to be this node pool has to be considered for static capacity or not. So it's a RFC based on that. Yeah, let me know if you guys have any thoughts and comments. I'm in the process of addressing Jason's comments.
Great. So basically just, is there any particular part of the RFC you would want wider consensus and review on?
I think the part uh, that is still a little bit unclear is whether we want to bound the number of nodes that the node pool or the cluster can go up to. Because what happens during the involuntary disruption is, let's say that if you have X amount of pods and if all X amount of nodes, then like if everything goes uh, like bad at the same time. So we would end up creating more while the old nodes gets terminated. They're stuck and terminating. So that might cause a lot more load on the API server than we originally anticipated. This is especially a call out for large clusters where we don't want to go above a certain node. Uh, so whether we want to introduce some sort of a threshold or a limiting factor on the nodes a node pool can have.
Yeah, I mean, that's where I know there's already been some discussion on the RFC around supporting limits for nodes. That's where I think that is probably the most natural semantic for this. I know this is something that we've been looking at supporting for standard node pools as well anyway. And yeah, because I think otherwise you definitely want some concept of a max burst. And yeah, I feel like being able to continue to make use of the existing limits semantic rather than introducing something specific for static node pools makes a lot of sense.
That was gonna be
Is
my next question is, yeah, how do we play into the existing node pool limits that we have here and the expected behavior that can be, like how we can use that to allow for bursting, et cetera, instead of having a different concept.
Well, I think
I'm
the
not
idea
super familiar with the existing node pool limits. Are they resource based or are they replica based?
resource based.
Yeah, so like
So, but a
not
node is a
really,
resource.
yeah, which
Wouldn't
like
we want to expand that to be replica based? Because in the static capacity, you're now talking in terms of like how many instances do you care about?
Well,
You're like outside of the realm of caring about resources.
well, that's a node is a resource, right? And so your limit on, like, let's say you
the same way a pod
have
is,
a
right?
replica count of 10 and you want to be able to burst to 15, you would just set your node limit to 15.
Ah, so there is an existing node limit.
I don't
Um,
I don't think there is, but it's something we've already been discussing adding for dynamic node pools.
I mean, would a resource-based limit like CPU or the memory make sense in a static context?
Like the combination of those things is what I'm also curious about. Like like whatever is more restrictive wins?
Probably, yeah. But I'm worried that we're like mix matching semantics here when we like in the static capacity case, you are asking the user to express their intent in terms of like a number of replicas. They're outside of the whole Karpenter experience of like, I just tell me how many pods you want and we'll make the capacity. You're actually asking, they're giving you an opinionated capacity perspective versus if you add and then like in the normal dynamic case, it is that kind of just express your desire in terms of pods and we'll figure out the capacity underlying it. But then you'd have to, would you support node limits for dynamic as well as like resource based limits for static? Is that what we're suggesting?
Well, like I said, there's already been the proposal to support node limits for dynamic, and there are strong use cases for that. Like, for example, if you have like networking limitations that mean that you can only support n nodes in your cluster, so you want to ensure that your node pool doesn't scale beyond that, regardless of how the resources are actually allocated. I don't see as strong of a use case for supporting resource-based limits in static capacity.
I suppose if you're avoiding like account limits, vCPU limits.
Sure. I mean, yeah, it's a question of how do you want to do the math? You
Agreed.
like if you have vCPU limits that you're aware of and you need to avoid them, you shouldn't scale that many replicas. I don't see a reason not to support resource limits for static capacity, even though I don't necessarily see it as being very useful. It's one of those things like there's a lot of configuration in Kubernetes in general, I think, that is possible, but not necessarily useful. Look at all the different ways you can configure topology spread constraints, for example. There's a lot of very useful applications for it, but there are some labels where it would never make sense to define.
Yeah,
So
so
I don't see an issue giving the lever.
I mean, we can always open up the limits eventually, like if we are introducing, if there is ever a need. The question is more on like whether we want to bound the number of nodes.
Well, I think the
Which,
natural thing is to just make node a supported limit for both static and dynamic node pools. And then just not don't have any special logic for limits for static capacity. Just treat limits the same way for static capacity as you do for dynamic.
you're saying that like the node limits are also being added to dynamic.
Yeah, yeah, that's kind of the whole premise for why I think it does make sense to treat it as a limit versus having this like special purpose burst semantic is we've already been talking about adding node limits for dynamic node pools. Like this has been a conversation in previous working group meetings. And yeah, I don't know if anyone else has any opinions on this, but personally to me, I think it makes sense.
All right,
Well,
I can build that in.
I was gonna say I'll have to read more about it because there are certain cases. I think there might be certain cases like close to limits in provisioning and consolidation that could be unexpected if this is added and you're close to those limits already. Like, yeah, I'm not sure. I'll have to just read and add some thoughts. Great. Thanks for sharing. Any other questions before we move on? If not, then we will go to the next PR. Don't schedule a pod with DRA requirements. Currently, Karpenter creates nodes that can't satisfy DRA requirements and keep trying to schedule a pod to a node. Karpenter should recognize that pods are DRA enabled and not try to create nodes to fulfill them.
Yes, hey Reed. So this is part of an overall set of hopefully quick DRA updates from our regular set of discussions. So Jason's driving DRA for Karpenter, and we meet every week, and we're starting to actually do some concrete work. Before going into detail about this PR, I really wanted to bring to the community just this proposal from a conceptual level. So right now, because Karpenter doesn't recognize DRA represents to Karpenter an additional set of metadata on the pod spec. So Karpenter effectively ignores it because it doesn't know about this new metadata. Specifically, they're known as resource claims. That metadata describes more complex scheduling constraints. And so an actor like Karpenter not being able to introspect that those scheduling constraints is not going to be able to reliably build infrastructure that's going to fulfill them. So the situation right now is if you are running a cluster that is DRA enabled with structured parameters, so it could be 132 or greater, and you're successfully using Karpenter, if you schedule a workload using this DRA metadata, then Karpenter will interpret it as a normal pod. So it'll evaluate how to build infrastructure to fulfill those scheduling constraints, totally ignoring where the scheduling constraints actually are. And so in a real world scenario, what you would probably have is just a continual sort of flapping where Karpenter builds some infrastructure, and then the part of Karpenter that observes that the pending pod is still pending will probably reap that infrastructure and try to build some new infrastructure and just go infinitely into that loop. Does that make sense as background to folks? Cool, silence of dissent. I think what this PR aims to do is to essentially instruct Karpenter to ignore workloads that declare DRA requirements. And this will be an interim solution until we actually have a DRA solution in Karpenter. So TLDR, I think there's a case to be made that ignoring pods that are pending with DRA scheduling requirements is the correct behavior for Karpenter. As non-intuitive as it may sound to ignore pending pods, because that's obviously the prime directive of Karpenter is to build infrastructure in response to pending pods.
Yeah. Granted, though, if Karpenter was aware of DRA, it would know that it cannot provision nodes to satisfy those DRA requirements and would choose not to schedule. So hence why this is more correct. The devil's advocate argument is by still allowing Karpenter to schedule it or to schedule these pending pods, you kind of give users a backdoor to if they want to start experimenting with DRA and continue to use Karpenter. They have an option for a way to do so. You could use targeted node pools to basically ensure that Karpenter is scaling up capacity that will support the resource claims that the pods request. It's fiddly. It's definitely not a great user experience for someone who wants to use DRA first. Like they're not just experimenting with it. But I did have the proposal that we could potentially just gate everything behind a DRA feature gate. Oh, Garvin, you had your hand raised.
Yeah, I was gonna say like it'll be nice to gate it and default it to not accept it, so it's easier to test in the future. But yeah,
Yeah,
The pro-
kind of this
yeah, the proposal.
going behind a feature flag that would allow people to mess with it, but have it disabled by default.
Well,
Yeah.
so I was thinking the opposite. The feature gate makes Karpenter DRA aware, and by making Karpenter DRA aware, at least initially, while we don't have proper support for DRA, Karpenter would start ignoring the pods that have resource claims configured.
right.
Is it more surprising to have incorrect or not appropriate compute provisioned, or for
That's really the question, actually. Yeah, that's the
Yeah.
question for the community, for the user community, maybe to weigh in on what is more correct.
Right.
Yeah, I mean, my opinion is that it is more correct for Karpenter to ignore the pods. Yeah, the question
Yeah,
is
maybe
really
the correct thing would be for
forward
Karpenter
backdoor.
to be able to introspect its set, like its portfolio of infrastructure that can provision, and to then sort of like affirmatively say, I can't provision infrastructure to fulfill this, and therefore I won't. So this is not exactly doing that, but it has the same outcome.
Sure, yeah, it's correct in the sense that as of today, you could imagine that Carpenter just doesn't believe that it can provision any nodes which support resource slices.
Cool. I don't think we need to solve this in this meeting. I just wanted to bring it up. I'd be happy to keep poking folks on Slack and maybe trigger if we can converge towards a consensus on the PR itself for folks who really have strong opinions, then trigger a sort of broader community lazy consensus.
Yeah.
So
I
I
mean,
just wanted to call it out.
I think the comment I have regarding the feature gate is on screen right now on the PR. So if you do have an opinion there, please feel free to go leave that there. And of course on Slack and such.
So Jason, you're definitely, at least from our team, I think the person with the most context on the feature. But is there any middle ground also where you're just ignoring these claims?
Well, that's kind of the middle ground I'm proposing that we could do is if the DRA feature gate is disabled, which it would be disabled by default, we just ignore the fact that the claims exist. That is what Carpenter does today. Now, this does mean you get into the situation which Jack alluded to, which is you
Spinning.
basically, if you do have a resource claim and Carpenter's not aware of it, you spin up a node. That node does not produce a resource slice to support that resource claim, and Carpenter eventually consolidates that node. Or, well, realistically, the pod just stays pending, and Carpenter keeps the node around because it's going to continue nominating it for scheduling, even though Cube Scheduler can't schedule it. So that would be the only advantage of that way is keeping a backdoor open for people to experiment with DRA if they want to make these targeted node pools. The kind of prior art for that is people want a similar backdoor for extended resources. And we've pushed back on that, waiting for node overlay.
Yeah, I would agree with that just because the middle ground will simply show up as like no churn or just Carpenter not doing anything. And I think historically we've seen a lot of issues with people like, hey, it's not doing the thing that I expected to do. Because it's something that Carpenter doesn't support. And I think like the approach of is all or none is better than in between just because it's very clear that hey, we don't support RA unless you turn it on. And even then it's like questionable until we're fully ready for it. So to me, it makes sense to be like, okay, disable it by default. And we say, unless you explicitly say turn it on, we won't even evaluate those.
So pods with the claims, kind of like this current PR, but with the feature gate.
Yeah.
Well, I think, Garvin, correct me if I'm wrong. What you're saying is you would prefer to see it that if the DRA feature gate is disabled, so the default state, Carpenter would not provision nodes if a pod requested a resource claim.
Yeah.
Backwards.
Yeah. Yeah.
Okay, that's kind of the opposite of what I proposed in my comment.
Okay.
So to be fair, I don't have a super strong opinion either way. Like I think my strongest opinion is probably like the correct thing is for Carpenter to just ignore it. The reason, like to ignore it whether or not the feature gate is enabled or not. Until
Oh, so there's
such a
okay, yeah.
time that Carpenter actually properly can introspect what resource claims a given instance type would be able to support.
Because this is
That-
an interim solution, would it make sense to just introduce a super specific ephemeral feature gate? Something like
Don't evaluate
exactly,
or something.
exactly.
Um,
Ignore DRA resources or something like that.
Or
Is it
respect
possible?
DRA, right?
Is it idiomatic within the community to launch a new feature gate with it enabled by default, or is that verboten?
I think we wouldn't frame it as a feature gate at that point. I think it would just be just a configuration option that we say like this is going to be removed in a future version.
Got it.
Personally,
Yeah, I mean,
I don't have
enabling it by default just allows us to use the ignore terminology. So it's like a human language thing. You could invert the semantics and say something like permit DRA resources and then disable that by default, for example. If disable by default is the more idiomatic from the configuration point of view, if that makes sense.
yeah,
But we
and
just give essentially you give users we change the behavior, which the community might decide is undesirable, which is building infrastructure that actually can't run the pod that it thinks it can run. We disable that behavior, and we give users an option to enable that behavior if there's an unanticipated, if we can't sort of just in case we're missing something where there actually is a useful configuration that someone in the community might want to use Karpenter in that way. So we give them an option to go back to the old behavior if they want.
yeah, and I do think there are some like one thing that comes to mind is if you have a resource claim that is requesting a device that isn't associated with a node at all. It's just a device on the cluster that's available to any node. I don't know if there's any like existing drivers or controllers that support that type of thing today. It is something that's made possible by the spec. But
Yeah, I mean, the spec is super flexible by design. I mean, it's
yes,
folks are working on CNI solutions. There's CPU for DRA solutions in the work, so it's going to be adopted for a whole variety of super interesting use cases. And many of those are going to be super vendor specific, and so they're going to depend on very specific drivers. So it's hard to pin DRA into a single thing.
yeah, that's where
I do think. Go ahead.
I was just going to say, because of that, I don't mind the idea of making a temporary flag where it's okay, we agree that the default behavior should be that Karpenter does not provision nodes for pods that request resource claims. But if you have a use case, you can go ahead and disable that safeguard while we are still iterating on the proper DRA support.
Then currently this is only observable via logging, right?
That it's being ignored.
Yeah,
Um,
at least the way that this is written, I think, right?
Yeah, that's what I have so far. But
Yeah.
I kind of assumed that that's all we wanted, right?
I think so. I mean, it's no different than any other pods that we say we can't support.
Yeah. Oh, quick question about the behavior where you can disable that temp flag and then it would create the nodes for the resource claim pods, but it won't be fulfilled. Are there users that want that behavior? Because to me, it seems like that's the behavior that we're trying to fix. So we don't even want this flag to ever be enabled.
So that's where it's backdoor. It's the main reason
Okay.
I could see it being, there are two scenarios where I see it being useful. A, you have that scenario where you have devices that aren't associated with any node. So you're not bringing up a node to support the device. The device is already available to the whole cluster. So for that use case, Karpenter doesn't necessarily need to be aware of it. Then the other use case would be if you want to use Karpenter because Karpenter is the scaling solution you already have installed for your cluster, but you also want to use some specific DRA feature. I think we've seen that customers are willing to make some very esoteric node pool configurations to make that type of thing work. So you could have a node pool that only selects on a given instance type and set specific like limits to ensure that you don't over provision for the number of devices that will be available.
Is that the kind of thing where you would actually trigger Karpenter? You would trigger the association between a pod and that node pool by adding labels or something else to the so something outside of DRA. So you know that once the infrastructure comes online, DRA is gonna the resource claims are actually going to inform
Mhm.
how the scheduling is sort of packed onto that infrastructure. but nudging your provisioner to create the infrastructure is not something that we can yet rely on the DRA spec exclusively to do. I see. Yeah, that makes sense.
Yeah, you would coerce Karpenter into making the right instance type selection choice via either like label selectors, taints, etc.
Yeah,
So
I could see someone doing that.
is it the way that I think we want people to be using DRA long term? Definitely not. But giving people an option to unblock themselves and be able to experiment with that or test it out, as long as we're clear that like this isn't really a supported path, this isn't the way we want you using DRA, we're not going to take feature requests, or maybe not feature requests, like bug fixes that are related to these bugs you perceive with it. I think it's fine.
It would seem to be, if I were a user, it might be just a lot easier to have Karpenter be in charge of all of my infrastructure except for my DRE infrastructure, to have another actor entirely be responsible for that. But
I would agree, but
yeah,
I've
we can
seen
give folks the
people
option. Yeah.
want a single source of truth. Just let Karpenter manage. Don't mess with needing to deal with Karpenter plus, in this case, in AWS, you'd probably be using MNG.
Yeah.
But yeah, no, it's like I said, definitely not a way. Like we wouldn't document that this is the way you can use DRA with Karpenter today. It's just, I wouldn't frame it any differently than it's a backdoor.
Great. I
Okay,
guess
cool. Yeah.
any other?
We can take it for further discussion in the PR itself.
Yeah, I guess the one other thing worth discussing is right now for DRA, we're basically DRA is a super big feature. There's a lot of surface to it. We're not going to be able to support everything DRA has to offer in an initial implementation. So one of the things we're focusing right now is really dialing in what subset of DRA features are important to support off the bat. So yeah, please, if you have any feedback on that, feel free to drop by the meetings we have on Thursdays. They're on the Google Calendar. It's basically just the opposite time of the working group, or like just shoot us a message on Slack and such.
Yeah, and that was actually my second bullet point. So I put structured parameters as that's pretty much a guarantee we'll support that. There's a dot, dot, dot. We discussed some other things in this morning's meeting, but the key concept is just to call that out as early as possible. There's a lot of stuff in DRA that's going to come to projects like Karpenter iteratively. Like there's no practical way for a project like Karpenter to support every possible DRA solution out there. So we'll
No,
do the
not-
big ones, and then as customers bring them to the project, then I assume that they'll just be like any other feature request.
Yeah, and it seems like DRA, it's not like the feature is even set in stone at this point. I've saw quite a few caps still in draft for DRA. So
Oh yeah, no, for sure.
all of the alpha ones that have already been merged.
That's right. That being said, structures, parameters, and a couple other ones, but mainly structure parameters is actually GA in 134. So
Yep.
it'll be enabled by default. So having some rational approach to how to deal with DRA starting with 134 is going to benefit any Kubernetes component.
Yeah. Yeah, structured parameters is the non-negotiable one for sure. I definitely want to see us be able to support time slicing, partitionable devices. But yeah, we definitely value feedback on that.
Cool. Anything else we wanted to discuss with that? I think we've pretty well covered it, but cool. Yeah, I hadn't totally prepared it, or had gone over it much, but has anyone had a chance to look at, I think it's pod headroom or buffers API, change it, or RFC?
Is it a published RFC yet?
I don't
No,
know.
It's in the autoscaling repo. I've certainly taken a look over a few times, and I know that it's somewhat contentious. I would
Yeah.
love to schedule some extra time to talk about that. I actually have to bounce for another community call. Thanks for have we discussed that? Has the community discussed that in this meeting prior to today?
I don't think so
Oh,
yet.
if we've discussed it at depth in this working group. Do you
Okay,
know,
great. Well, go ahead.
Jason, do you know if we've talked about it? And
Oh, yeah, I just said I don't think so.
yeah, I don't think
it's
we have.
been mentioned, but we haven't actually talked in depth about like what would it look like for Karpenter to support this? Is it feasible? Are there any changes we would need to see, etc.?
Yeah,
Yeah,
'cause-
it's been brought up at the SIG Autoscaling meeting, and similarly, like I think we need a separate meeting. So why don't I be on the hook for organizing folks from that meeting and from this meeting who are interested to get together and see where we can go. The idea is for Cluster Autoscaler and Karpenter to come to agree on a common proposal, essentially, so that there would be a standard API, but that's difficult. So
Yep. Yeah, I think that sounds like a good next step.
Yeah, appreciate you putting yourself on the hook to put that together.
Mm-hmm.
be in the firing line.
Yeah.
I'm good at dodging.
Cool. That was the last thing that I wanted to bring up. So if anyone has anything else they want to add, give like a couple seconds here. Otherwise, I think we're actually good to wrap up. Awesome. Thank you, everyone. Thanks for joining, and we'll see you next time.
Bye. Thank you.
Thanks.